Alright, so I have this setup here, okay, with 300 micro Henry inductor and a 0.39 ohm resistor, okay, just two of them in a circuit, okay. And I just want us to see the exponential rise and the exponential decay of the inductor. Okay, I have an input coming in from my power supply. Okay, so I'm going to just make contact with the input, and then we're going to see what happens on the oscilloscope. Alright. Okay, so we have exponential rise. Okay, so let's place our horizontal lines. We can observe to see the exponential curve that starts at this point, okay, gets to end about this point. Then we have steady state after that. Okay, so if we look at T here, we have 342 microseconds for the time between where the rise begins and where it ends, right? And remember, we're using 300 microhenry inductor and a 0.39 ohms resistance in series. So we have a positive voltage coming through here, the resistor, and then goes out of it, going into the inductor and coming out of it. Okay, so I have a 555 timer here connected in a way I would get a square wave of about 1 kilohertz frequency and approximately 600 microseconds pulse width. Okay, so I'm going to be connecting it to this one so we can get to see how this inductor reacts to the square wave, both the rising edge and the falling edge of the square wave. Connecting the 555 timer to our oscillator, we have what we see on the screen. Okay, so let's connect this now to our inductor network to see what the response will be. So we have this, okay, so we can see that it's visible that, of course, this is where we had our square wave, okay, the yellow line, and we had our inductor wave here. So it's clear and it's visible that the inductor didn't move as fast as the incoming signal. Okay, there's a delay in movement. All right, it takes more time. It resists that instantaneous change. Now, the signal coming out from the 555 timer isn't automatically just instant. It has its own delays too. All right, but if you watch down here, you see that the inductor delays further. So you can see the property we talked about for inductors. It resists change of current flow. Okay, so there's no instantaneous change for inductors. Okay, once it senses that change, it would give off a resistance and cause for the change to happen gradually. So you can see that move here. All right. Okay, so we can see the same thing on the falling edge. You can see the same thing on the falling edge. Okay, you can see that it doesn't allow for instantaneous drops too. So you can see it's slowed down the process here too. It slowed it down at this point. So basically, inductors will always resist instantaneous changes, right? And would create for those changes to happen quite slowly.